Today we are going to see the Gauss Jordan method. Now, it is a direct method. Already we have seen Gauss elimination method. In Gauss elimination method, we have changed the matrix to upper triangular matrix. But in Gauss Jordan method, we are going to represent this system of equation in a form of matrix, and we are going to reduce the matrix to the diagonal matrix. This is the system of equations we are having, that is 10x plus y plus z is equal to 12, 2x plus 10y plus z is equal to 30, x plus y plus 5z is equal to 7. We are going to solve this system of equations using Gauss Jordan method. First, I am going to represent the given equation in a form of a matrix. First column represents the coefficients of x. So 10 I am writing 2 and then 1, y coefficient which is 1, 10, 1, and z coefficient which is 1, 1, 5, and the constants are 12, 13, 7. And I'm going to make this matrix as a diagonal matrix using the row operations. My matrix is this one, that is 10, 2, 1, 1, 10, 1, 1, 1, 5, 12, 13, 7. Just I have collected the coefficient of x is first column, coefficient of y is second column, and coefficient of z is third column, constants are fourth column. And I'm going to make this matrix into a diagonal matrix by using the row operation. First, I'm going to make this element as 1 by dividing the row 1 by 10. So I am getting 1, 1 by 10, 1 by 10, and then 12 by 10. The remaining row as it is, that is 2, 10, 1, 13, 1, 1, 5, 7. Just I have divided the row 1 by 10. So I have mentioned the row operations here. Uh, the second row, first row, second element, and first row, first column, the third element as 0. Now we have to make the second diagonal element as 1. So I am writing the first row as it is. And I am going to write the third row as it is. 0, 9 by 10, 49 by 10, 29 by 5. Because my aim is to reduce the second diagonal element to 1. So I'm going to divide R2 by 49 by 5. So that already here we are having 0. So 0 divided by 49 by 5, it is 0. And the next element is 49 by 5. So you are dividing 49 by 5 by 49 by 5, which gives you 1. And 4 by 5 divided by 49 by 5, which gives you 4 by 49. And then 53 by 5 divided by 49 by 5, which gives you 53 by 49. Now our aim is to make this element and this element is 0 using the second row. That is very important. So I am writing the second row as it is 0, 1, 4 by 49, 53 by 49. I'm writing the second row as it is. And I'm going to change R1 as R1 minus 1 by 10 into R2. Okay, just I'm changing the row 1 as R1 minus 1 by 10 into R2. So this term becomes 1, this term becomes 0, and R1 is 1 by 10. 1 by 10 minus 1 by 10 into 1 by 10 into the corresponding R2 element is 4 by 49. If you simplify this, you will get 9 by 98. You can do it in calculator. Okay, just you can use AB by C form. So 1 by 10 minus 4 by 490. If you put in calculator, you will get 9 by 98. Similarly, 53 by, sorry, 12 by 10. The next row 1 element is 12 by 10. 12 by 10 minus 1 by 10 into 53 by 49. So I am getting 107 by 98. Now I'm going to make R3 as, because I have to make this element as 0 using row 2. So R3 minus 9 by 10 into R2. This row operation we can do. So if you do like this, you will get 0. This is 0. R3, which is 49 by 10, right? 9 by 10 into the corresponding R2 element is 4 by 49. So you will have 473 divided by 98. And this element also becomes 473 divided by 98. Next, our aim is we have to make this element as 1. So I am writing the first two rows as it is, that is 1, 0, 9 by 98, 107 by 98, 0, 1, 4 by 49, 53 by 49. But I have to make the third row, third element as 1. So I am dividing R3 by 473 by 98. So that you will get 0, 0, 1 and 1 here. Now our aim is to make this element as 0 and this element as 0 using R3. So you write the third row as it is, right? And I'm going to use R3 so that this element becomes 0. So R1 is changed as R1 minus 9 by 98 into R3. So the first two elements will be 1, 0. The third element will be 0 because 9 by 98, that is your row 1 element, minus 9 by 98 into the corresponding R3 element, which is 1. So which get cancelled. So you are getting 0. And the next element is 107 by 98. Okay. Minus 9 by 98 into the corresponding R3 element, which is 1. So if you simplify this, you will get 1 here. And now I'm going to make changes in R2. Our aim is we have to make this 4 by 49 as 0. So I am writing R2 minus 4 by 49 into R3. so that I'm getting 0, 1, 0. The corresponding R2 element is 53 by 49 minus 4 by 49 into the corresponding R3 element, which is 1 here. So 53 by 49 minus 4 by 49, which gives you 1, right? So you are having this matrix now, that is 1 0 0 1 0 1 0 1 0 0 1 1. We know that the first column represents x coefficient, the second column represents y coefficient, and the third column represents z coefficient, and this represents the constant. So this is x coefficient, right? So x coefficient is 0, y coefficient is 0, and z coefficient is 1. So z is equal to 1. And what about this? This is y coefficient. So I am writing y is equal to 1 because x coefficient is 0 here, z coefficient is 0 here. And this is x coefficient. So 1 into x, which is x, the remaining coefficients are 0. So x is equal to 1. So x, y, and z are 1 here. So what is the difference between Gauss elimination and Gauss Jordan? In Gauss elimination, we will reduce the matrix to upper triangular form, but here we are reducing to diagonal form so that we are getting the answers directly in Gauss Jordan method. See here, we are getting from the third row, we are getting z value. From the second row, we are getting y value. And from first row, we are getting x value. But it is not the case in Gauss elimination method because we have to do back substitution. This is the main difference between Gauss elimination and Gauss Jordan method.